Hi everybody, what we're going to do in this video is cover how to do data screening in Excel. So if you've watched the data screening lecture video, you've seen kind of the basic gist of data screening, what the different things are to consider, and we're going to do our very best to cover all of that in Excel with the caveat that it is rather limited if you're not using a program like R or SPSS and some of the options. So I'm going to kind of show you the best way to handle the limitations of only using Excel, and hopefully very soon JASP will have a lot more of these functions. Okay. So the first thing you're going to want to do if you don't have this installed is install the data analysis or the data stat pack. So if you want to know if you have it or not, click on data, and it's going to be over here and it's going to say data analysis. If you do not have that, click on Excel. Where is it? Tools, sorry, Excel add-ins. So Tools, Excel add-ins. And then on a Windows machine, you have a lot more options, but on Mac, this is all you've got. So click on these two here and click OK. You do need to be using Excel 2016, I believe. I don't think this works in 2011. And Windows, various versions of yours have included this data analysis feature. Remember, if you're taking my course at MSU, you can download for free from the university the newest version of Office if you do not have the newest version to be able to do some of this stuff. Okay, so we're going to work through the data screening in order that's mentioned in the lecture video, because remember, and I really like to ask this question on quizzes, the order matters. So me changing something from one point to the next will affect my analysis. Okay. So the very first thing I'm going to do is save this as an Excel file. The data set that's online is a CSV file. Remember, CSV files are what opens in JASP. But to do some of the things we want to do, I really want to have all of the features of full Excel. So I'm going to do File, Save As, and we're just going to call this data screening data. I'm going to stick it in another folder, and I'll upload this file. And I'm just going to say this is the Excel version. Now, don't just hit enter. Come down here where it says CSV and make it an XLSX. Okay, hit save. And really what that's going to let me do is add multiple tabs. So this data set here is our master data set. So if we screw something up, copy and paste wrong, do something wrong, we can always come back to the original master data. So I can't really screw a whole lot up here. I'm going to click the plus here to create a new tab. And this is the data set where we're going to fix those no typos. We're going to fix any problems that we have with any typos or categorical issues with the data. Okay. So to do that, I'm going to copy the entire sheet. So if you click here on this little triangle, that will highlight everything. You can do edit copy, but I'm going to hit Command C or Control C to make it copy. Come over here to no typos, Command V or Control V to paste. Okay. So right now these are the exact same data set, but I don't want to screw up my original data, so I'm going to leave this here as master and only come back to it if I know I've made a mistake and I have to rewrite this. Okay. And so this is a lesson learned the hard way, that you want to make sure that you don't, that you save these as separate sheets. So if you make a mistake, you only have to back up to the previous step. You don't have to back up all the way to the beginning, or heaven help me, you edit the only data set you have. So this is just a way to keep track of what you're doing. Okay, so what I have here is a really messy data set with lots of missing values and several hundred lines from a student's thesis project. The original data set had like 900 columns, so I'm going to try to condense it down and kind of show you how you can do this with only a few columns. But we've got their gender, their school level, and advising. Now all three of these should be categorical columns, but our advising one is not. So for whatever reason, we forgot to code this correctly. So I want to fix that first. So the first thing you always want to do is fix your categories, because categories need to be done correctly, to import correctly, and they're labeled right and that sort of thing. And so I'd want to change everything here in my advising column to, instead of being 1s and 2s, to being their actual labels. So I'm just going to highlight everything here, and we're going to use the find and replace feature to fix any issues. So I'm going to click the little down arrow up here, click replace. I'm going to replace all of the 1s with assigned advisor. Okay, because that's what that was. Click replace all, and it will fix all of them in that column. Now, if you don't highlight that column, it's going to replace everyone in the data set. Don't want to do that. So be sure you have the column highlighted first. Now I want to fix all of the 2s with no assigned advisor. Replace all. And I knew that because I worked with this data set, and I specifically wanted to show you guys what you would need to do to fix a categorical column. Another thing is, if you make the mistake of letting people type in whatever they want. So let's say you wanted to ask for someone's race or ethnicity, and you just let them type it in. It's going to be all over the place. Some people might say white, some people might say Caucasian. Like, you never know what people are going to write. So instead of having a clickable option, you just let them type. Well, the first thing you're going to want to do, if you have that sort of column, is go through and code all of those so you have consistent categories. And so one thing you can do to look at the categories that you have, and this is a favorite cheat of mine, is highlight your categorical columns. It will help if they're always at the front of your data set. So I'm just going to hit Command C here. I'm going to hit the little plus arrow here, and I'm going to paste them into a blank sheet. And so all that does is it just puts them somewhere else so I don't screw up the original one. Click on Data here. I'm going to highlight my first column. I'm in the Data tab. And then just click Remove Duplicates. I'm going to say OK. And so now I can tell that I have just male and female. So I don't have any weird spacing issues. I don't have any, some people who said woman and some people who said man. They're consistently coded as male and female. I can do that same thing for all the other columns. So remove duplicates. And this will just show me all of the different levels that I have. Oops, wrong one. That's my other favorite button. Here we go. And I have no assigned advisor and assigned advisor. So that just shows me that I don't have any weird extra categories that I wasn't expecting. And so that looks pretty good to me. Now I might want to go through and capitalize these, but that would be up to you if you wanted to go ahead and make them proper case. Since we're making graphs in Excel separately, I don't really need that right now, but that's another option. Okay. So I don't need to save this. If you want to leave it in Sheet 2, you can, but that was just to me to check. And what that does for me, let's hit delete here, is it allows me to know that these 3 columns are good. They have the data I expect them to have. Okay. So first thing you always kind of want to look for is accuracy on your categorical columns. Make sure the labels are there and make sure the labels are what you expect them to be. Okay. Step 2 is to look at the accuracy for continuous columns. So that's everything else out here. Okay, so all 23 of these columns here. Okay. So to do that, what I'm going to do is click my data analysis. This is going to help us do a couple of different things. I'm going to come up here to descriptive statistics. Hit OK. Now I've already highlighted them, but for some reason Excel doesn't pick up on that, so I'm going to re-highlight the columns I'm interested in here. If you just watched the graphs video, hopefully none of this crashes. Okay. We're going to leave this grouped by as columns here. Okay. And I do have labels in the first row. If you have labels in the first row, be sure you click this or it will have a fit, because these are words instead of numbers. Okay. I'm going to tell it to stay in a new worksheet, and then I can tell it to give me summary statistics. If you don't click something down here, it will be grumpy with you, but summary statistics is the one we want. Click OK. That'll take a minute, but now I have my summary statistics out here. So this is descriptives by column. Okay, or by variable. Let's call this variable. And so what is everything here? I don't particularly love this output because it repeats this column every single time, but that's okay. So it gives me the mean for each column. It gives me the standard error for each column, standard deviation, variance, median, mode, skew, and kurtosis. So this is really nice. It's very similar to what JASP will do for you. But it also gives me the min and the max. So that's what I'm really interested in. I want to make sure there aren't any values outside the range that I would expect. And there are, because I made this data set up just to have some values that are incorrect. And so question 2 here has a 9. This is a 1 to 7 scale. So that anything over 7 is bad. So this is something I'm going to want to fix. So I'm going to highlight that. The min and the max here are okay. Here they're okay. Question 5 here has some bad values. 0. I keep going. Oh no, here's another 0. That's no good. Here's another 9. So these columns have values that are not appropriate. Here's another 9. And here's 2 more issues. So you can see I purposely screwed this data set up just to make sure to show you how to fix this. Now, if you're using online survey software like Qualtrics, SurveyMonkey, this is going to happen less often. If you're typing your own data, unfortunately, it happens a lot. So I've got several columns that are problematic. So I got to fix that. So we're going to come over here into no typos, and we're going to fix it. Now I have all the columns I'm interested in highlighted already, and we're just going to do find and replace again. Okay. But one thing I'm going to do is I don't really want to change the names of my variables here, and if I do that because they have numbers in them, it's going to freak out. So I'm just going to highlight all the data, because I don't want to screw up my variable names. And what I'm doing to get it to highlight like that is I highlighted the first row, and then I went down to the very bottom one and held down Shift at the same time to get everything highlighted. So I'm holding down Shift to get all of these columns highlighted. Okay. I'm going to click up here, do replace. We want anything that is a 0. And I don't know what that point should actually be. So the problem is that that's a data point that shouldn't have happened, and I don't really know what the real number should be. If you know what the real number should be, replace it with the real number. Don't lose that data. Go back to your worksheet, find participant 4, and fix the data point. If you are like we are and you don't really know what the number should have been because it's all in the computer, you're going to replace it with nothing. So I'm going to actually leave this blank. I'm going to hit replace all, and there were only 3 zeros. It was a 1 to 7 scale, so I want to replace any 8s that might be there. And it's 7. I didn't find any of those, but we know we have some 9s. So we'll hit replace all. I have 5 of those, because I'm not very creative when making up fake data. Now, I'm going to rerun that data analysis just to make sure it fixed everything. So click data, data analysis, descriptives, same old. Same columns I was using a minute ago, same labels, etc. Hit OK. It's actually going to give this to me on a brand new sheet. So we can delete this one, or we can kind of look at it. Question 2. Did we fix question 2 here? So question 2, it's now 1 to 7. So just kind of scroll across here. I'm looking at these 2 columns, rows. 1 to 7, 1 to 7. 1 to 7, blah, blah, blah. I know I'm scrolling too fast, but they're all 1 to 7. So now I've fixed all of these problems. So I'm going to get rid of that. Now I'm going to name this one by variable. Okay, for a reason that we're going to get to in just a second. But that's the way that you would fix problems with your continuous variables. So we're fixing out of range scores, so scores that are not within what we originally want, what the scale of the data should be. Now this isn't people you don't like, this is just scores that are not part of the scale of the data. Okay. All right, so for missing data, you're very limited when using Excel, quite unfortunately, for missing data. And so what we're going to do is we're going to calculate by variable, and we're going to create a new sheet. Sorry, we're going to let Excel create us a new sheet. And we're going to do by participant. So I'm actually going to click data analysis again, descriptive stats, the same thing that's been set up, hit OK. This time just click rows. Okay. Now I don't have labels in my first column, so I don't have each participant number out here on the side. Now I could add that, that might make life a little easier, but in general we're just going to click rows here. Okay. Click OK. Input range contains non-numeric, hit cancel, cancel, sorry, my fault. I can't have that first row highlighted because it has words in it. Scroll all the way down to the bottom here, hit shift, click here. Now I have all of the data highlighted, right? And so we want to do data analysis, descriptive statistics. Okay, now I want to do rows. And now the input range is wrong. We need to highlight it while we have this open. There we go. And that's annoying because I actually have to pull. So let's go all the way down here. Now, if you're good at Excel, you can type the formula in. But showing you the slow way. And by formula, I mean this craziness. Okay. And now, finally, we should get the descriptives. Okay. And so this is by participant. Okay. Now, for missing data, what I want to first do is exclude all participants who have more than 5% missing. Okay. So if a participant has more than 5% of missing data, then they're a problem and we need to get rid of them. Now you'll notice I excluded my categorical columns here, so I don't have this column for people here. So this technically is missing for these participants as well, but I wouldn't make that data up ever, right? We wouldn't just guess. So I'm really focusing here on the continuous data. And there are lots of ways you could do this, so if you think of a faster way, that's fine. I can show you both ways that you might be able to do this. But what I want to do here is take this count. So this count thing here tells me the percent missing per person. So there are 23 columns here. So what I would do is hit do equals 23, or click on this number here, divided by the number of rows, columns times 100. Okay. So this person has 100% of their data. And I could do that same thing across all of this, but that's going to take me a long time. So this person here has 0% of their data. And so that's going to be kind of the slow way to do this, but it's one way to do to look at each person at a time. Okay. And so if you're scared of formulas, this would be the way to do it, but it's going to be kind of slow. So let me show you the other way. First thing I'm going to do here is take all of this and create myself a new sheet. So let's do that. So this new sheet is going to be no missing. Sorry, I gotta highlight, copy, paste. Okay. So for my no missing data set, I'm going to create myself a marker here. So I'm going to go out here. I'm going to say percent valid. Okay, call this whatever you want. And this is going to be the formula. So let me make this a little bigger here. I'm going to do equals count A. Count A is a function that tells you how many of the cells that you highlight have text in them. Okay. I'm going to highlight the whole row for that participant. I'm going to try, come on Excel. Okay. So here, I want to highlight the whole row, if it'll play along here. So I'm going to I've still got to focus on the continuous data, but you could use these other three columns. Okay. And so count A tells me how many valid data points they have. I'm going to divide that by 23 because I know that there are 23 columns. So 23 is not a random number here, it's the number of columns that I'm using. And then we'll multiply by 100 so I can think about this in percentages and not proportions. So that gives me that they have 100% of their data. Now I can double click here to fill the formula, but that only works if the entire, sorry, I won't cheat just yet. That only works if the entire row if it has a data point here. So instead what I'm going to do, so see how it changes from a white plus sign to a dark plus sign, is I'm going to drag this down where it's the dark plus to the very last row, which is 300 and something here. Okay, it's going to run very slowly because Excel hates me today. There we go. And so that'll tell me their valid percent. So this is how much data that they have. I can only replace data if I have less than 5%. So if I wanted to get really fancy here, what I can do is take 100 minus this score. But I don't even need to be fancy. Now what we can do is sort our data by this column. So I'm going to come over here, I'm going to click A to Z. It's going to sort everything. So it sorted all of the data over here. And it told me that all of this is 0%. They have no data. Okay. So all of these people basically just didn't even fill out the survey. Okay. Or they filled out the first little bit and quit. So let me scroll down a little more. Or they filled in just a couple of little random points here and there. So I don't want to use these participants because if I don't have enough of their data, I cannot use them. So essentially what I want to do is take all of these participants that have this missing data that's more than 5%. So they got to have at least 95% of their data. So only 5% missing means 95% valid. And I'm just going to delete them. Okay. Now, that's a little bit scary, but remember we have them over here in these two tabs. So I can get rid of them without too much worries here. And it's a lot of people, yes, like 97 rows or something. But these people just don't have enough data for me to even use. Okay, so I need at least 95% of their data. Now we could delete them and then put them back in later. So let's say that they have all of scale number 1, but not a whole lot of scale number 2. Well, you can't really use them for scale number 2, but you could use them for scale number 1. So you might just want to like siphon them off, put them in a special tab of like people with partial missing data. But for our purposes right now, just to show you how this works, we're just going to get rid of them because we can't do anything with them. I cannot fill this data in. I would be making up an entire participant or a whole lot of their data. And remember, they're still in the no typos and the master data set, so they're not gone. They're just gone from this particular tab. So right click, delete, go away. So now what I have is participants that are only missing a couple of data points. And I can do something with this. So that's by participant. Now, by variable, here, I'm going to move this over here. So I could do it this way, but that's going to be really slow. And I would have to figure out, okay, row 23, delete row 23. Okay, so see here, with row 4, I would have had to get rid of row 4 and row 5, and that's just going to take you a long time. So this by participant thing is not even very useful, but it is a way to do it. So I'm right click, I'm just going to get rid of it. Because using this percent valid thing out here is much faster. Now what I can do now is do that exact same thing for each column. Okay, so we're kind of Lego breaking this off. So I've cut off the participants that aren't valid, like they quit the survey or they didn't finish or I just don't have enough information about them to use them. And now I'm going to go to the very bottom of the data set, okay, which is now 273, to calculate by column. So I'm interested in this by rows and then by columns. So how did I get from the bottom to the top kind of quickly like that? In Windows, hold down the control key and then push the up arrow or the down arrow. On Mac, use the command key, and that'll kind of go faster. Exact same thing here. So do equals, count A, highlight everything. So I can hold down Shift here to highlight everything. Divide by how many rows are there now. So now it's not 23, it's how many rows are there. Okay. And actually what we could do, if we want to get really fancy, is just do count. Count just tells me how many rows there are. So I would highlight everything and divide. Okay. So count A tells me how many things have text in the cell. Count just tells me how many cells I highlighted. So you can do that on the other side too, if you are bad at math like I am. So let's do times 100. And now I have 100%, so I'm just gonna do the exact same thing I did a minute ago. I'm gonna wait for the arrow to change from white to black. Drag across here. And now I wanna look at these. And that should not be 100%. Because obviously I have a missing data point here. So maybe count is not doing what I think it's doing. Right? Because I know I have a missing data point here. Oops. For some reason it gave me everything is 100%. So maybe I am not doing that right. It worked yesterday, but Excel has been a big pain. So let's just do this manually. So how many rows do I have? I have 272. So I have 271 rows because I can't count the first row. There we go. That looks more right because I'm only missing one data point. So I'm not sure why count and count A gave me the same number, but they did. They're supposed to give you different numbers. All right. So here I want to look for anything that's less than 95%. And these all look pretty good after I deleted those problematic people. So what do you do if one of these columns is less than 95%? Don't delete it, but highlight it. And we will not fill in data for that highlighted column. Okay. So essentially you just wouldn't do what we're about to do to the highlighted column. So to finish off our no missing here, because I can fill in, so I can fill in anyone who has less than 5% missing from rows and columns. Now what I want to do is calculate a number to put in here. This is the most inelegant solution, but given the very, very small amount of data we're about to replace, it's a solution that would work. So we would be able to save these couple of people that only really are missing one data point because maybe they didn't click on something that you needed. And so what you want to do is calculate the average for each column, and we're going to fill in the average for that column. So I'm going to hit equals, I'm going to type average. I'm just going to highlight that whole column again. Now, I don't want to use my average from before because that included people that maybe had some missing data. So I guess I could if I wanted to, but you probably don't. Take the average that I had here for question 1, 2.52, and fill that in. But that wouldn't be the number without all of those other participants. So I'm going to drag and drop that across here. So we're going to fill in these missing data points with the average. So I've got 2.51. Now if you want to, you can also round this up to 3 because that would be the data point that the person would have put. So that's also an option where I'm forcing it to be one of the numbers that someone might actually pick because I just rounded up. Or you could just type in this number. So I got 2.51. So I'm going to go find that missing data point. So the nice thing about the shortcut that I just taught you, by using Control or Command and using the up arrow, you will go straight to that data point. So here I would type in 2.51. Okay. And so now there's no missing data in this spot. And so our number here should go to 100. I can fill in this column, but it's 2.48. Okay. And I'm going to keep going. So 2.10. Now, mean substitution has its opponents, 2.41 here. But for a very small amount of data, I don't know that it's any more, it's really not going to make it significant if it wasn't before. It's just going to let you keep a couple more people in the data set that you worked hard to get that data. Obviously, in ANOVA type data, where you only have one column for each person, you're not going to be able to fill data in. So this only really works when you have very large data sets, this procedure. Okay. In a perfect world, you would use something like M plus or R that has a multiple imputation procedure, but that's not really practical for people who don't have those sorts of programs or those skills. So if we're going to use Excel, this is a way that we can estimate. So 3.38 for this one. I missed one of them. There were two here, so 3.38. Oops. Now I could round that to 3, don't forget. These are 100% already, so 2.49. Okay. Need to go to the bottom here, so 2.84 on this one. Now that's 3 data points, but it's 3 data points out of 270, so it's not really a whole lot of the data. It's less than 1, it was about 1 point something percent. So 2.63. So yes, this will be a slow procedure if you have lots of columns, but it won't be very many data points because you've already deleted people that have more than 5%, and you will not fill in columns that have more than 5% missing. So you would just skip over that column and let it stay at 95 and less. Okay, so now everybody has 100% valid data, and I have filled in my missing data. Like I said, slightly inelegant solution, but at least it is a way to do that using Excel. Now, traditionally here I talk about outliers, except Mahalanobis distance is kind of a nasty thing to calculate in Excel, so I'm going to recommend using z-scores. Z-scores for each individual column would be very slow in a big data set like this. So we're actually going to kind of switch 2 of our assumptions here and then try z-scores in a different way. Okay. So I'm going to highlight everything again and just create myself a no outliers data set. Copy this, paste this. Now one thing I'm going to do is get rid of my percent valid stuff out here and then down at the very bottom, because I don't really need that anymore. All right, so with a large data set like this is even a huge data set, this is, one questionnaire, it's going to be kind of tedious to check each individual column for whether or not a person's score is an outlier, but you could. What I'm going to recommend here is checking it by scale. So if you have this type of data and you're going to end up creating total scores anyway, check the total scores for the problem. Okay. So what we're going to do is I'm going to go ahead and create my total score. Now on this particular scale, I think there were 3 subtotals, so I would check each subtotal separately. But for example, I'm just going to create one overall total score and I'm going to check that. Okay. So I'm going to add that here on the end. I'm just going to call that total score. Okay. Now to create a total, so a sum, I can use the sum function, so equals sum. Woo, that was a fun typo. A highlight going this way. I do not know what is up with my Excel today. It's been a big pain. So all of the numeric options here for that scale, and then I'm just going to hit enter. So this person's total score, because we filled in one of their data points, is 5038. Click on this. I can double click here to fill in the entire column, or if I have some missing data points, I will drag it down to the very bottom. Okay, but I don't have any missing data points anymore. So here are all of our total scores for each participant. To create their z-score, what we're going to do is we're going to calculate a z-score by hand. So the first thing I need to know is what is the mean of this column. Now here's a fun trick in either program. Highlight the column. You could have done this a minute ago too, but clicking and highlighting it would have screwed things up. So highlight the column, and then down here it actually tells me the average. And in Windows you can actually click on it, I think, and change which one you see. So I could click to see standard deviation or see the sum, but in Excel for Mac here, automatically see the average. Okay. So what we're going to do is do equals, open parentheses, the other one here, this score minus that average. So the simplest way to do this so that you don't screw yourself up typing is do minus, type the word average, open parentheses, just click the entire column here. So I want the average of this particular column, close parentheses. Okay. So I've done that score minus the average, closing the second parentheses. So we're just telling it to do this in a particular order. So making sure it doesn't ignore our please excuse my dear Aunt Sally rules here. Do divided by, and the function for standard deviation is STDEV. Okay. Open parentheses, click the entire column again. Okay. And that's going to create a z-score based on that column. So the function for z-scores is that particular participant's score minus the average for that column divided by the standard deviation. Now, you could calculate descriptives using our data analysis feature and just manually type those in as well. But this is a little more flexible because this doesn't require you to transfer numbers back and forth. So I'm gonna enter. And so this person's score is slightly below average. So z-scores, a 0 means they're right on average. Higher scores are bad. So I'm going to double click to fill that in, right? And it will auto-populate. So that means that it's taking now this person's score minus the mean divided by the standard deviation. Okay. Don't forget these parentheses here at the beginning. Otherwise, it's going to take the average divided by the standard deviation and then do like this score minus the average divided by the standard deviation, which is not mathematically correct. Okay, so be sure you keep in all the parentheses that I had a minute ago. Okay. So I think if I double click, you can't totally see it, but you'll be able to look at this file and see these functions again here in this window. So I have people's scores that are slightly below average, above average, below average. And so the negative sign here tells me that these participants' scores are below average. The positive sign means they're above average. Okay. So I'm going to click here, and now I'm just going to sort people. So I'm going to hit A to Z here in the data window. Okay. And what we're looking for is a cutoff score of 3. So what that is it's the big important rule. Okay. So the big important rule is that we only want to fix people if their scores are really, really nuts. And so we're going to use p less than 0.05 for hypothesis testing. We're going to use p less than 0.001 for data screening. Okay. And that'll become important to remember all semester, because when we get into looking at Levine's test for ANOVA, we're not going to use 0.05 as our criteria. We're going to use 0.001 because we want things to be really, really nuts before we decide to do anything else. So we're setting our alpha value for hypothesis testing at 0.05. We're going to set our criterion for data screening at 0.001. Okay. And so the z-score at 0.001 is close enough to 3 that most people consider it 3. Okay. I think it's actually 3.1 something, but everybody uses 3. This is one of those common rules that you'll see cited in a lot of places. And so we want to look for scores that are less than 3, so negative, or greater than 3, positive. Okay. And so I have some negative scores here, but none of them are 3, so these are all fine. So now I'm going to hit Z to A to get the other way, and I have some scores that are above 3. So all of these participants are 3 standard deviations away from everyone else. So what does that mean? That means that their scores are less than hold on, I have to do 2 decimals in my head here, 0.1%, right? That means that their scores are really wild. If you consider everybody else's data, these 4 or 5 participants scores are so high that they're 3 standard deviations away from the mean. Okay. which means that their score's likelihood is 0.001 proportionally, or 0.1%. So what are we going to do with them? We're going to delete them. We're going to kick them out. Now, you could decide that you don't want to delete them because you have a small sample, or you just don't think their impact on the data is that high. You can test this with and without outliers if you like. I'm going to get rid of them because these participants' scores are too high. So I'm just going to delete them. Right click, click delete. Right, so that is a decision that you would have to make. Now, what happened? This one participant now is greater than the mean, but they weren't a minute ago. So I hit Control Z. Oh, or maybe they were, and I just cannot, I'm not viewing this column correctly. Okay, just kidding. So I should have deleted all of these people. Okay, and delete. Shift cells up, that's fine. Okay, now here's what happened. These people here were, good grief, what are you doing to me, Excel? Okay, I didn't do it wrong the first time. Excel's being wonky. So these people here, I'm gonna delete. All right, now when you recalculate, this person is now an outlier. Do not double delete, okay? So don't delete people twice. So in the original data set, these people were the outliers. We're getting rid of 1, 2, 3, 4, 5 data points out of 270. Hit delete, and then ignore the z-score. So do not double delete because this person was not an outlier before. Okay, so that's our no outliers. From here, I'm gonna just kind of create myself a final data set. I'm gonna highlight everything here, paste it into here without the z-score column. Now, if our next thing gives us some problems, we might have to go back and reconsider those z-scores. So if we decide, hey, I decided I didn't really want to delete those people because I actually have this other issue we're about to get to, I could take my no missing data set, copy it into no outliers, and try that outlier thing again. So if I screw any of these up, I delete when I shouldn't have, or just get distracted and hit the wrong button, which is likely to happen with the squirrel that I am, I can back up and copy this no missing data set and fill it in here and just work from here. So that's why I've been creating and saving these in separate tabs. It's because if I mess something up, I can just back up one tab or one step. Okay, so now let's check the assumptions. So first assumption we're going to start with is additivity, which means that I don't have multicollinearity. Multicollinearity is too high correlations between columns. Now, if my point here is to just use a total score, I don't really have a problem because I only have one number I'm using. But if I'm interested in using each column separately, then I might consider checking out the correlations between them. So let's click Data Analysis. I'll come up here to Correlation. Click OK. And we're going to tell it to give us all of these correlations. So I'm going to click here, highlight all of my columns I'm interested in. This is something JASP will actually do for you too, but we're going to stick to Excel because we're just going to do everything in Excel. I want to group by columns, so by variables. I do have labels in the first row. Click OK. That is hopefully not going to crash. This is why you hit save a lot. There it goes. It just was really big. Okay. So here's my correlation table. Now, this gave me every column correlated with every other column. So if you're working with, like, say, 900 rows, don't do that. It'll freak out. But 900 columns. Instead, I could do this by scale. So I could take scale number 1 and look at it, and scale number 2 and look at it. Okay. Now, it's going to be kind of hard to see what might be problematic here. And so what we're going to do is use a little highlighting trick to see which columns are over 0.9. 0.9 is our criterion for multicollinearity, which means that the columns are too correlated to use together. Now I could create an average score, which is what we've already done, but I couldn't use them both in the same analysis because mathematically that was going to cause us some issues. So this kind of fun highlighting trick, I'm going to highlight all of these. Now remember, these ones here are correlated with itself, which we've seen in other correlation tables, but I'm going to ignore that one. And to get this highlighting, I'm going to click Home, Conditional Formatting, Highlight Cell Rules, Greater Than. Okay, so Home, Conditional Formatting, Highlight Cell Rules, Greater Than. We're going to do 0.9. So everything greater than 0.9. Or if I want to be really fancy, 0.89. Okay. And we're going to look for anything that's highlighted. Now it automatically highlights text for reasons unknown, but we want to look for any cells that are highlighted other than these ones here. And I don't have any highlighted, so that means that none of these are problematic correlations. Okay. So since I don't have any correlation problems, my outliers are fine. If I decided that I wasn't going to use question 21 because it was way too correlated with everything else, I would have to redo outliers here. But otherwise, I'm fine. All right, now the next step here is probably the most complicated thing we're going to do. And Excel will let you do multiple regression, but it is really unhappy about it. So in cases like these where I have a lot of columns, what I traditionally tell people to do is to do a multiple regression using each and every single column. The problem with that in Excel is that it just doesn't wanna, and it only will do up to 16 columns. So, knowing that this isn't a perfect world, we're gonna take only the data we're gonna use. So we're gonna use this total score. And that total score is going to represent, a sum or an average of every single column. Now, if I have a problem, if I notice that the total score is really wonky, and I know I'm going to use each one of these columns, I'm going to go back and do this one column at a time, which is slow, but it's doable. And so in this case, I'm only going to use the column that represents the data I'm going to use. So if you're going to use a total score, just test the total score. If you're going to use every single column in some way, like let's say a factor analysis, you might want to test the total score, and then if it's really bad, test it in like chunks of 5 questions or something, because that's just a limitation of the program we're working with. Okay, so all that being said, we're just going to work with our total score here because we know that's what we're going to use from this data. And I'm going to create a random variable. Okay. And so in the video I talk about why is this random. Well, we're creating a random variable to test our assumptions against, because if we predict a random variable, the residuals or our mistakes, the errors, should also be random. Okay. Talk a lot about doing this as random chi-square. But in Excel, it'll work the same if you just use the rand function. So we're going to do equals rand. Okay. I do think it has a random chi-square function, but rand will work just fine. So rand, open and close parentheses, and that's it. Okay. This is going to give you a random normal variable, but do know from the lecture that traditionally what you want to do is a random chi-square variable, because this sort of thing is chi-square distributed, but once we take the standardized residuals, everything becomes normally distributed, and there's quite a rant about that in the other video. Okay. So equals rand. I'm going to highlight this cell, double click when it becomes the black plus sign, just so that I have a random variable for every single column. Every single row. Goodness, can't get rows and columns straight. Now, every time that you hit enter, it will change, usually. Each one of these will change every time you do something. There we go. Every time you type something, they'll change, and that's okay for our purposes. It does mean that you and your friend sitting next to you will not have quite the same graph, and that's okay. So now we're going to predict our random variable with our total score. Okay. And this is where we really have to have the data analysis pack. So we're going to click Data, Data Analysis, And we're going to come down here to regression. This is a fake regression because we're not really going to use a total score to predict a random variable. That doesn't make any sense. So I always talk about this being a fake regression because this is where we're going to just look at these assumptions. If we're doing real regression, we would not create this random variable. So when we get to regression analyses later in the semester, we'll do this example again, but we won't use this random variable thing. We'll actually predict our real y variable. But in this case, we're testing this because we have categorical variables. So let's say I'm interested in the difference in the total scores based on categories. Well, that I would do an ANOVA on. So this would be a way to test this for ANOVAs, t-tests. So I'm going to click regression, hit OK. First thing is the input y range. So for y here, we're going to highlight our random variable. Now for x here, I'm going to highlight my total score. I might have several columns. So you might have 3 total scores, or you might have 3 questions that you're interested in. Right now I only have 1 just for simplicity's sake, but I might have 3. I got this to work for 5 or 6 columns. It'll say it'll do up to 16, but it's a no. It wouldn't work for me. So you could probably do about 5 columns at once if you were interested in trying this with multiple columns. I'm going to click labels here because I do have labels in my first row. We're going to get the standardized residuals because we're interested in the z-scored residuals. Residual plots because I don't really want to look at those. Line fit plots, which is our, I don't know actually that we need line fit plots, but let's just ask for everything. And then normal probability plots. Okay, sometimes called PP, or from the lecture, QQ plots. And hit OK. Okay. And it's doing this thing again where it does not like me. Man, I got this to work a minute ago. So what did I have to do? Okay. I think I only highlighted, I didn't highlight the, whoops, sorry. Scroll happy there for a second. I didn't highlight the first row. Let me try that. Okay, so I'm gonna turn off labels here. All right, so you might have to not highlight the labels. It's finicky. So try it with the labels and see what happens. If it freaks out, try it without. Okay. So mainly all of this, I just want to ignore. Okay, we don't actually want to look at this. This is not anything we're interested in. We're mainly interested in these plots over here. Okay. So because I'm interested in them, I'm going to make them a little bigger. I'm going to hit save because Excel's being cranky. I've got my line fit plot here, which I don't know that I want to use, but I'm actually, okay, what are you doing? There we go. I'm actually really interested in this plot as well. And then there's one more plot we're gonna have to make. So I think from the notes I did normality first. So let's do that one first. What I'm gonna do is I'm gonna take this column right here, this column that says standardized residuals. And I think this will work a lot better in Excel when we don't have very big data. But I want to take, good grief, it created me all these extra sheets here. Okay, so I was going to call this sheet assumptions because that's what we're doing. Okay. And I really am interested in these standardized residuals, so I'm going to highlight those. Okay, so I'm going to go to the bottom here. Highlight all of that. And we're going to create a residuals histogram. Okay, now you saw pictures of these in the lecture, so we're going to create one of those, and it takes a couple steps. So I'm going to click on Data, Data Analysis. I'm going to come up here, I'm going to go down to Histogram. Hit OK. Oh man, we got to highlight again. I keep thinking Excel is going to be smarter than I am and highlight what I want for me, but that's a lie. All right, so I got all this highlighted. All right, and now let's just say under output range, just stick it in the same place, just stick that thing right there. You can put it in a new sheet too, that's fine. All right, and let's see if it'll actually give us the chart by clicking chart output. negative. Okay, I was hoping it would, but it wasn't. So it gives me this thing here. What I want to do with this thing is click Insert, Recommended Chart, and you can pick frequency. You can do any one of these frequency charts. I like this one because it's bars. Okay. Now, it's created these bins for us. Right? So it binned the data for us. And what we want to see is a nice normal distribution. So it would be better if we had a little more control over this particular chart, and we could say, okay, give me bins at 0 and this and that and the other. But this is the sort of quick and dirty way to get it. Okay? So I want this to be centered over the middle, which is generally 0. So here's 0 right here, and then I want it to be fairly even on each side. Okay? So this is actually kind of rectangular. Which isn't totally perfect, but you know, we'll survive. And then here at 0, most of the data is between 2 and 2. So I would say this is okay. It's not perfectly normal because it's kind of a little rectangular, but most of the data is between 2 and 2. Okay, what you don't want to see is centered around 0, wherever 0 ends up being. Okay, this is really tiny. Okay, so here's 0 between these 2 points. Is you don't want to see the data ranging from, like, let's say -1 to 5. That would be bad. The other good news is that we have at least 30 participants, which means that for normality's sake, it'll be okay. So we can assume normality with at least 30 participants. Oh, it did give us the histogram. That jerk. He put it up here. Sweet. I'm sorry, I didn't see that. Woohoo! Okay, so let me go over how I got this chart one more time since I didn't realize what it was doing. Okay. So what I did was I clicked Data, Data Analysis, Histogram, clicked OK. I highlighted the standardized residuals right here. I clicked Chart Output. I told it to stick it right there for me, and OK. Yeah, that's fine. And then it hid the graph from me. So here's our graph. Yay! So you don't have to do that extra step. Woohoo! So we make this bigger just so I can see it, so it looks exactly the same. And so most of the data is between 2 and 2. I have at least 30 people, so I would say this is okay. It will take looking at a lot of these before you get kind of comfortable with them. All right, so that's normality. Linearity is up here, and so it's this normal probability plot. And so what you want to see is it looks like a line. And this is like perfect. Man, you can't make up data this pretty. So you want it to be a straight line out of 0. And so one thing you can do here is tell it to add a trend line. So right click, add trend line. And you want most of the dots to be along the line. You do not want it to make a bow shape like this or to kind of sine curve around the graph. So this is a really pretty graph. So that is mostly linear, like almost perfect. So that's linearity. Then the last graph here is this residuals plot. So the residuals plot here is for homogeneity and homoscedasticity. And it drew me a nice line here at 0, and I wish I could make it draw a line vertically, but just kind of imagine a line here up the middle of this graph where the x variable axis is. So for homogeneity, across a 0 here, we want the spread of the data to be even. Okay. It runs from -6 to 6. That's really even. And the spread is nice and even across through here. Okay. Now, is the spread even left to right? So if I imagine my imaginary line up the middle, it's fairly even. We got a couple little scragglers out here, but in general, this is fairly even across the x variable here. Now, we could, in a perfect world, make this a z-score as well, but it's going to be way too much work, so we're just going to kind of imagine a line up the middle. So for homogeneity, I would say this graph is okay because the graph is centered over 0 vertically and horizontally. Now, for homoscedasticity, across 0 here, the spread has to be roughly the same. Now, I know this sounds exactly the same as what I just said, but what you could have is a a plot that runs from, let's say, 1 up here and a 5 down here, which would not pass homogeneity, where the spread around 0 is not the same, but the spread across the graph is relatively even. Okay. So homogeneity is about the 0 point, the middle. You want the spread to be the same on either side of the middle. Homoscedasticity is about just ignoring all of the lines, is the spread is the same all the way across the graph. So to do that, I always just kind of draw a line around what I'm doing, and if it's blob-shaped or square, it looks fine. My favorite graph that someone has actually drawn the line on was Chuck Norris roundhouse kicking something. So if it makes a picture to you, then that's usually a bad thing. If it makes a triangle, that's a bad thing. UFO shapes where it's skinny on one end, fat in the middle, and skinny on the other end are also bad. So this graph actually passes both of them because it's even across 0 and it's even all the way around the graph. So it's not lumpy. We're more concerned about lumps for homoscedasticity. Okay. So all that together is data screening hacks in Excel for traditional data screening analyses. What you would then do is take this final data set. So I would delete my random variable and import that into JASP. So I would just kind of highlight everything, save it as a new file, and be sure you save it as a CSV. Okay. So in this particular assignment, we're just going to be practicing data screening. You won't have to do that, but let's say for the next assignment, you will have to take your data screened data and import that into JASP. So you're going to get a lot of practice using Excel as well. So if I wanted to do that, what I would do is highlight everything I've been working with. So I do want to use my total score here. Highlight everything. Copy. Create myself a new file. Paste. File. Save as. Okay. Be sure I change this down here to CSV. And then give it a useful name, like final data screening. Okay. Okay. And this is a file that I can port into JASP. Now it'll tell me, do I want to save the changes? You can say don't save. I know that's counterintuitive, but there's something about CSVs that it always does that for you. So that is how to go start to finish data screening that you can use across any analysis. If you're lost or you need help, be sure you leave us a comment, or if you're in my class, please come to the help desk hours and we will hold your hand while you work on one of these just so that you can feel more comfortable with using Excel.